Hi, everyone. Welcome to the NLP session. So I'm going to talk about how we're using NLP in extracting out key, named entities out of the patient chart, massively scalable system using AI, and how we're impacting our business as well. So let me quickly start with a quick introduction about myself. So my name is Jayant Thomas. I'm head of AI and machine learning at Chain Healthcare. I'm in the process of transitioning to other job as we speak as well. So I'll keep you all posted. So my background, my passion is applied machine learning and AI. I've been doing this for many years at GE Digital, and I started working on industrial IoT machines using telemetry data, identifying any anomalies, and preventing any downtime for this machine. So the way we have built that is a platform-centric way as well. Like so essentially, the whole idea is to build a platform for IoT machines, which can then you can process massive amount of data and then get the inference out of it. So we built out a platform from ground up, and it was very successfully deployed in multiple use cases across various different industries as well. And subsequent to that, I joined a company called Veritas as head of AI and ML, leading the machine learning data initiatives at Veritas. So we built out a platform called as Veritas Predictive Insights for their storage appliances. The idea is to provide a 360-degree view of the appliance health of the appliance, as well as the use of the appliance, how much capacity it has got for the next 60 days, 90 days, and the next year as well, using forecasting algorithm specifically tuned for that particular volume as well. And subsequent to that, I've been leading the AI and ML, engineering at Change for the past 3 years. So we built really a powerful AI platform which takes care of faster application development, AI and ML application development at scale for various different healthcare use cases, all the way from NLP extracting key entities out of charts, which I'm going to talk today, as well as conversational AI, which can basically provide a patient with a better experience, essentially identifying the intent of the calls and and routing the caller to the appropriate agents, or even doing self-service activities such as scheduling patient for their appointments or canceling their appointments, or even refilling the prescription. Those are the interesting use cases we have done as well. In addition, we have done applications related to a lot of claims processing, and as well as clinical decision support as well using NLP. Um, the agenda for today is to sort of go over little bit of how we do AI application development using the concept of AI platform. Just want to go through that, and how we have built a set of Lego pieces using which you can application developers within Change can build out application at scale and then launch it within few weeks, rather than building out those microservices or services themselves. So that's one. That's the first part of the application, the presentation. I'll walk you through that, and then subsequently I'll walk through a specific use case, how we are sort of using the platform to build an NLP based solution, and I'll also walk you through some of the business opportunities and some of the how we did the training and the prediction process, and a little bit on the deep neural network architecture as well, and close up with some metrics and as well. So in Change Healthcare, the way we do our application is using this concept called AI platform. So what is AI platform? So AI platform is nothing but a shared environment for machine learning and AI for Change Healthcare. It's built using core cloud components like native cloud services from AWS and GCP and other services, and it's one of the pillars of the Change Healthcare platform initiative as well. Our mission is to accelerate the outcomes by augmenting the data with intelligence. The idea is to extract out all the intelligence out of the data and then sort of curate that in a knowledge graph type scenario where you can build application on top of it. So we want to expose all these capabilities as services or microservices as reusable feature, and that can be leveraged by for building any AI application within Change Healthcare. So the idea is to build no code, you come with a requirement, and you can just use some of these Lego components and build out your application pretty fast and scalable way. Yeah, just want to provide a little more, depth into the concept of the AI platform. So the way we have structured this AI platform is it's a contributable or decentralized platform, so that anybody within the organization can build and add to this AI platform, build services and add more services. That's the way we expanded the AI platform. So far, we have built around 25 applications using AI platform, or what we call it the AIP, and it is consists of 35 services all the way from OCR, labeling, inference, training, and many different applications. It's completely decentralized in nature and collaboratively built by all the developers within the organization. So anybody can come and say, "Hey, I want to contribute to that or change some of the piece of it." So it's built for that, and it's built for the network effect. So the whole idea is using when you contribute to the platform, you expand the value of the platform by adding new services, and at the same time, you can use all the services within the platform as well. Um, Essentially, you can contribute and share, and it's pretty much heterogeneous. So each of the services can use any of the cloud native services you have built as well. So it doesn't need to sort of use only AWS services or any one vendor. It could have heterogeneity in the sense like you can use any of the services from different vendors as well. An example is for OCR, we're using GCP, which is Google Cloud, OCR engine versus for inference, we're using SageMaker. So that's the way we operate. We take the best of the breed and sort of build out the application, on build out the service on top of it. And the other few capabilities I can say is once you build a service, so we have some key tenants, it has to be scalable. Obviously, it's a cloud native service. You can easily scale it, and you should be able to share the service. So we have a mechanism where I can sort of you can discover the new service someone has built, like a labeling service, and start using it using the AI platform. And it should be simple, so it's basically our idea is to build a very simple, elegant way of accessing and using the service. So we have provided a simple CLAI, which is a command line interface using which you can sort of call these services using APIs, standard APIs as well. And it's adaptable in the sense you can basically change this and morph the service using YAML files. I'll give you some examples in the next few slides. You can configure the service using basic YAML files, and it will configure it for your own use cases. So that's one of the beauty of this services. So all of these things are packaged in this AIP services. Like I said, there's around 35 services. Many of these services deals with data services, data catalog, data processing, OCR, and like there's like a few other services called modelless services, where we sort of extract the model and generalize the model for many different use cases. So we built modelless services. We also built labeling platform and many different types of inference services, like real-time inferences, batch inference services, and other types of services as well. And so we also have built out conversational AI services on top of it, like so you can build any conversational AI applications using this AIP as well. So let me give a quick overview of. So typically in an AI platform, everything is a service. So you can see here there are two components to it. One is a broker, which basically takes care of the cloud necessities, the life cycle, like creation, deletion of the service, billing, and tenancy. So it takes care of the broker, takes care of all the those are standard interfaces we provide to take track those like necessities. Then you have the executor. Executor is the key ingredient, which is the code that does the actual job. So and provide the needed mechanism to execute. Like for example, OCR service. The OCR engine is the executor. It could call an external. In this case, it's in the example I gave you. It's calling an external OCR engine, but it makes it scalable. And so you can like instead of there are a lot of limitations in calling the OCR APIs. So this one provides additional enhancements where you can scale those OCR APIs as well, and that's what we call it as a service. So like I mentioned, AIP is a set of services. It's very easy to use. Like you can see here, I'm using the command line here. I call the command AIP create instance of OCR service. You get a OCR instance, and you can then execute. Basically, you can say, hey, OCR this tons of PDF files. Each PDF file could be having tens of thousands of PDF files. So this one basically takes care of processing, taking the whole PDF, splitting it into smaller chunks, and then sort of executing this entire service, entire PDF file into converting that into JSON files as well. So that's what this one does. And then if you want to do training, so you can then create an instance of training service. And then you can create a workflow on top of it. It says you OCR those files and then sort of train my model using this OCR output. And it's just 3 lines of command. Like you can see here, in this case, I'm just doing is training the OCR, OCRing the files. Then I'm wiring that up with the training service with the YAML file for workflow. I'm just saying, hey, this YAML file has got the first step is to do OCR, and the second step is to do the training. So it does it very elegantly, and you can kick it off in three lines of code. So that's the beauty of the service. And like I mentioned, so it's a AIP is a set of services. Then we call this as Lego blocks. It's a set of pluggable service. Then you use those services and create a composite service. And eventually you can create a combination of pluggable service and a composite service to create an AI application here. You can see here I have a list of pluggable services like a workflow service, a scoring service, training service, batch inference service, or an API service for real-time inference in this case. So I can create, using these, I can create a composite services. We do have something called a depot service, which is a composite service of few of these applications, and OCR service as in another example. It uses some of the additional services to create its own service. And then eventually you can create a machine learning application by plugging in, wiring up all these services to create a powerful machine learning service as well. So that's sort of the power of thinking in terms of the platform and how we can scale, building out these applications as well. So let me now switch to how does it help in a real world scenario. So I'm just going to use a small example, where today in our business unit, so we basically manually split some of the patient records and then feed it to a third party service to do some additional NLP services, extract out ICD codes, things like that. So that's the opportunity that presented to us, and it was a pretty manual process. You had to go through this many different times. It's slow because there is a human being involved, and it's laborious because you have to split you know thousands of pages into different encounters. It's not a very pretty thing to do, and it's not a highly efficient way of doing things as well. So because we want to get this out as fast as possible to our customers, but the manual process takes a lot of time. So this is a simple example, you can see here. So you have this big medical record coming from the patient record, and you want to split it into encounters. So the idea is to split you know, historic patient record into different encounters, and each encounter is nothing but one visit to a hospital. So that could be an encounter, or you go to a laboratory, you want to do some work, so that could be an encounter. The idea is to split into different encounters, then you extract out the ICD code out of it. So today this process is manually done. It costs us a couple of dollars, to do this activities, although it's outsourced to outside US. So it costs us around $5 to $10 for this activity. The solution. So we came up with this. Essentially, all the patient records goes into this data lake. In our case, which is essentially Amazon S3, and then we try to do the data cataloging. So in this case, we extract, catalog those data, which basically says this particular patient record comes from this feed, and that's the data catalog. So we do catalog all the data, and then the first step we had to do training, labeling and training of the models, because as you can in the subsequent slides, I'll explain you why we need to do that. Because the idea is to split into different pieces. So we need to do the training of the models. So for that, first thing we do is OCR. So the OCR service I talked about basically is used here. So we can use, in this case, we're using, GCP for the OCR service. From there, we have a labeling service. The user we import those OCR documents into the labeling service, which has a UI as well. So you can do labeling of the text. Essentially, in this particular case, the data scientist basically took the first 10 words in front of those encounter dates, and then that's sort of the labeling they did. And then they created, using the training service, they created a model, and this loop goes on multiple times, the training and experimentation, till the data science team is satisfied. Then they publish it to the model catalog as a service. So some of these models can also be generic in nature, so you can make it as a model as a service. So in this case, it's a segmentation service, or encounter direction date. It could be used in multiple use cases, so we made it as a model as service. Then you need to deploy this as you can deploy it as a real time, endpoint model, or it could be in this case we deploy it as a batch and inference, because that's the use case we had. So you can see here the bottom is the inference pipeline. So the top one is the training, the bottom is the inference pipeline. Inference pipeline does the same thing. So it gets the data from data catalog, and then OCRs. That's the first step it does, and then the model gets executed using the batch inference service. Since it's published as a batch processing, it gets in. We use the batch inference service to execute the model at scale. So we have a SLA of around 6 hours to complete the entire batch of charts. So we use the batch inference in this case, and eventually the inference gets stored in a RDBMS, and it could be exposed to the API, or it could be sent. The output could also be sent as a feedback to the end user as well. So that's sort of the high-level architecture. So you can see here um, in the detail, like you can see we are extracting 10 words before and after the date was selected. And then we use positive samples, negative samples to train our model, which is a deep neural network model to identify each encounter. So once in the real prediction process, then once the encounter date is identified, so we do some post processing to screen out certain additional data, or like sort of so we added some additional logic in this case to correctly split, because we want to have a high accurate precision split. So that's sort of the one of the requirements, to have up to 98% accurate splits. So that's one of the reasons we did this post processing, and then we identify the encounter. So that's sort of a little bit detail here. And you can see here, this is sort of the typical neural network, architecture for this procedure. So we take the first, 10 words, and then do the word embedding, and in this case we used bidirectional, LSTM to do this, training of the model, and identifying the encounter is the final phase of a director encounter dates, and based on that we can do the split of the pages. And this was successfully rolled out, and we got around 70% split rate for this particular use case, and we exceeded the 55% target rate for this particular use case as well. And one thing I want to point out is the whole thing was done in a very rapid fire fashion, because we're able to sort of reuse many of this infrastructure already, the service is already built out. So we went live in 3 months from start to finish, which was pretty commendable given the circumstances. We were able to launch this pretty effectively, in a quick burst and quick iterations as well. So that sort of covers my presentation. A quick recap is so we believe in using a platform-centric approach to building AI application using a set of microservices. And as I've gone over one of the use cases, it enables us to go to market pretty fast and effectively as well, and with the low cost, low in development costs and high efficiency as well. And thank you again for listening to this presentation. Looking forward for your feedback and questions. Thank you.